So let's start ourselves off with a little check on the audio. This is Oscar, and Oscar says... So I know my audio is working. Fabulous. So my name is Laura Kalbag, and I am going to talk to you about modeling a better night's sleep with state machines, state charts, and a very cool white noise machine. So I've been working in tech for around 15 years or so. I've worked in all kinds of teams. I have worked in design, I've worked in development, I've managed projects, I've been part of other people's teams. And one of my biggest pet peeves is this false divide that is created between all of our different roles. Like, you know that designers end up creating, planning architecture for engineers, and that engineers always end up filling in for designers where they're missing resources there. Project managers end up doing all sorts of things. And we're constantly creating this false sense of separation. We're constantly passing documents between each other, requirements and feedback. It's really difficult to work together. And sure, there could be better ways to communicate, like we could employ some clever processes, we could set aside our egos even, but sometimes we just need some tools that are going to help us work better together. And because this is an engineering-focused event, I'm going to come at this from an engineering perspective, and we're going to talk about managing your application logic and managing your state. So let's start off with some issues that we commonly find around state management. We have complexity. So the bigger the app, the harder it is to manage state. Like, even adding the tiniest feature can end up with adding so much complexity to your state. We have data flow. Passing state between components can get really complicated and hard to follow if you're trying to track how that data is flowing around. We have concurrency, so when different components are trying to read the same state simultaneously, you can get into really tricky situations. And we have testing and debugging, because the more states you have, the much harder it is to isolate and reproduce those state-specific issues. I mean, if you've used a lot of Booleans to manage your state, you will know what I'm talking about. Let's be honest, a lot of the time, the sum of your application logic is kept in some engineer's head somewhere. I mean, if you're really lucky, it's kept in multiple engineers' heads. But what happens when they go off sick, or when they go on holiday, or when they quit? Then you get a little bit stuck. So I'm going to build a basic white noise machine app. So I got this one to help soothe my dog's anxiety. He really hates fireworks and he hates thunderstorms and it makes him scared. And white noise is a really great way of blocking that out. And I got this really cool physical little white noise device. If you have babies, you might know of a similar one. And it makes this lovely soothing sound. And he gets all happy and goes to sleep. So I kind of built a strange digital version of it. And let's think about some of the states that might be involved in this. So this is some very scruffy handwriting you have from me here. We've got on and off. We've got play audio and pause audio. We have different white noise sounds, because why limit yourself to white noise? Why not have waves and a fan? Colored lights, because who doesn't love colored lights? And if it's on the web, it's nice to do stuff with color. So we've got yellow and green and blue. And I'm going to also look at having volume up and volume down. So enter finite state machines. Now raise your hand and keep it up if you are familiar with state machines. Put your hand down if you learned about them in computer science. Yeah, there we go, I thought so. And wave your hand if you've actually used them since you learned about them in computer science. OK, how many of you use XState? Not enough, OK. So a finite state machine is a model that can only be in one state at a time. So here, my example, I have paused, which is a state, and I have playing, which is a state. And you can change from one state to the other in response to some kind of input. So play is an input, it's an event, and pause is an input as well. And so on the play event, we transition to playing, and on pause, we transition back to paused. Very importantly, there is this little icon here, which is like a blob with an arrow coming out of it that is pointing to one of the states. And this is a key concept. It's our initial state, because of course, if you are starting a state machine, you need to know what state you need to start in. So that's our initial state. State machines are also a really excellent just visual representation of what your code should be doing. And you can use state machines everywhere. They're really helpful if you want to model complex flows, like chatbots or onboarding flows, multi-step forms. If you ever try to do one of those without a state machine, you will wish you used a state machine. And any kind of workflow or prototyping, that's really useful to use a state machine for that too. Whether you're in front end, whether you're in back end, I mean, to be honest, even if you're in project management, state machines can do it all. So I'm going to create a state machine for my white noise app. Now here's the point where I jump out of the comfortable keynote and into the wild west of the browser. So here we go. Here is my initial state. See how big that is. OK, a little bit bigger. So this is my machine, my initial state. That is going to be power off. I know it's an odd concept to have power off on the web, but I'm rolling with that kind of physical metaphor. And then I'm going to toggle the power. So that's my event, and that is going to transition into power on. So far, very finite state machine. So next up, we come to our actions. Let's see that one. That one, thank you very much. So actions are fire and forget side effects. They're the kinds of things that you want when you get into a state to say, make this happen, I'm not going to think about it again. And so we're going to add some triggers for our machine here, and we're going to add the implementation details later. So this is a great way of thinking about your application logic from a higher level. So what I'm going to do is, when I go to power on, I'm going to add an entry action, and I'm going to show the buttons. And when I do power off, I'm going to hide the buttons. And just to be extra sure, when I exit power on, I'm going to hide the buttons there as well. Belt and braces, good design. So this is a very, very simple state machine. Next, I'm going to introduce you to a very exciting concept that is called state charts. So if you've heard of state machines, you've seen that diagram. You know how they work. But state charts are where things get really exciting and actually genuinely a lot more useful. So state charts are a visual extension to state machines that allow us to model way more complex logic. So first up, we have hierarchy. So we can now have parent and child states. So inside of our power on state, I'm going to add a child state, and I'm going to call it sound. Actually, I'm going to go straight into white noise. There we go. And then I'm going to toggle my sound. And I can toggle that sound. So just think of this one button. I'm pressing a sound button. And that is going to go to fan. And I'm going to toggle again. Love me some toggles. Quite straightforward when you're writing the code if you do it on toggles. And this is going to be waves. And I'm going to go back to here and toggle the sound again. There we go. You can see what that's doing. We're kind of going around in a circle. And of course, each parent state, so this is now our parent state, the power on state, needs its own initial state. So we're telling it when we go to power on, the first sound will be white noise. I'm going to add some actions in there as well. So I have an entry action on white noise for change to noise. And on my fan, I am going to change to fan. I'm typing quite well today. This may not last long because I'm terrible at typing. Very inaccurate. Change to waves. I've jinxed myself, I swear I have. Right. And next up, we have parallel states. So parallel states help us solve the problem of concurrency. So when you want two states to be active at once. So what I'm going to do is I'm going to wrap all of this in another child state. So this is going to be my sound state. I'll pop that in there. And I'm going to add a light state, running out of space on this tiny screen. There we go, so scrolling. And I'm going to add a volume state. Whether a state is the right thing for volume is up for debate. If anyone wants to have that debate with me later, we can go for it. I'm willing to be wrong. And inside my light state, I'm going to have light off. And this is going to be a very familiar situation. Oh, I'm going to toggle the light, because Laura loves toggles. And then yellow, love yellow. Yellow goes first. Toggle light. Gonna go blue. Oh, not blue. See, I did jinx myself by saying I was doing better at typing, and now I'm not. And toggle light. And green. And go back to light off. I'm usually trying to make these really tidy. There we go. That's a bit better. Now, I've got all of these unreachable states going on. If I zoom in, will I be able to see that a bit better? An unreachable state. No, that text is still small. It says unreachable state. Trust me at the back. And so now what I want to do, that state is unreachable because there's no transition that will take me to those states, but that's because I want them to all happen concurrently. So I'm going to take my power on state, and I'm going to make that into a parallel state. And now everything has these dashed borders around them, and that represents the parallel state. So anything with a dashed border around it, it can be active simultaneously. So I'm just checking, I've got to add everything. Yes, right, need to add some actions. So on my light off, I'm going to add an entry action, because when the light's off, I want the light to go off. It's technically a color rather than a light, so I'm going to call that action remove color. Then for yellow, I'm going to set yellow. For blue, set blue. And for the green one, I'm going to set green. So I now have entry actions for all my light-related states. Hopefully that is big enough to see. I go really big for a second. There we go. The bigger the state machine gets, the harder it is to fit into a tiny space. So here I've been kind of starting to use the terms state machine and state chart interchangeably. And that's because, as I said previously, that state charts are a visual extension to state machines. And so everything that is a state chart is also a state machine, but not every state machine is a state chart. And if you care about that, you're as sad a person as I am. But I like to be precise. So next up, I'm going to hide the UI. That might give me a bit more room. There we go. I'm going to add some self-transitions. So self-transitions are really helpful when you're in a situation where you want to keep the state, but you maybe want to have an event happen, but then return back to the same state. So that's why I've done this for volume. I'm going to create a self-transition. So you can see the arrow comes out, and it goes back in. And this is going to be volume up. I have semantic diagrams as well. I know we were talking about the importance of semantic HTML before, but when I'm talking about volume up, I want it to be above. And when I'm talking about volume down, it's going to be below. Everything has meaning. And volume down. And I want to add an action for that. I'm going to call that vol up. So this is, all these actions are going to be what triggers all of my really delightfully written JavaScript that you will see in a minute. I'm also actually going to add, I'm going to add an assign action. And for that, this is a very special kind of action. So what I'm going to do here is I've actually got the volume to show my content. Here I have the context for the entirety of my machine. And what I want to do for my context is I'm going to set a volume by default, and I'm going to make it 5 by default. So I have got a value that I want to store outside of the state, and that's going to be my context. And so what I'm going to do here is when I do the volume up, I'll assign to the context. And what I'm actually doing is I'm going to increase the volume in the context. And because it needs loads of curly brackets, I have actually kept it here. Because otherwise, I'm never going to type the right brackets there. Oh, good catch, Laura. You typed volume up there, and you wanted volume down. And an assign action that assigns to context, assigns to my volume, and I'm going to reduce the value that I have in the context there. Great. That looks nice. Fabulous. Have I done those? Right. I also need to make sure that when I first turn on my state machine, I have another entry action that I want to add in here. And that is going to set the volume. Because it's really annoying if you go back to turning something on and it's kept the same volume from before. I mean, sometimes maybe in a physical device you want that, but if it's something on your screen and you go back to it and it's suddenly really loud, that's no good. So I'm just going to set the volume there. Now, I don't know if anyone has thought about the logic of my machine here, but I have a bit of a problem that I can't actually turn volume up infinitely or go volume down infinitely. I mean, volume up infinitely, that get pretty loud. Volume down, well, you can't go quieter than no sound at all. So I want to guard my transitions here. I want to add some conditions for them. So what I'm going to do is I'm going to add a guard. And for this condition, I want to say if is not max volume, and if is not min volume. So what this is saying is when someone hits the volume up event, if it is not maximum volume, then trigger those actions. And if not, ignore it. And the same goes for volume down. And this gives us the conditional logic that we needed. It's pretty readable as well. It's pretty handy. So going back, another concept that works really well with state charts is the actor model. Anyone here heard about the actor model before? No? One, yeah. One or two, one or three, yeah, that's it. The more I say it, the more people are going to put their hands up. If I keep talking, you're all going to have heard of it. So the actor model is where everything in a system is an actor. So an actor can send and receive events and change its behavior based on those events. So we can make our logic a lot more maintainable and a lot more modular by breaking it all down into actors. So I'm going to do this with an audio player actor. So with something like an audio player, that's probably the kind of logic you do want to break into its own sort of little component or section. Because if you think about stuff like audio, you might want to, I don't know, add a really cool MIDI interface to it if you've watched Rowdy's talk. And so that will make it much easier to test and debug as well if we're keeping that logic separately. So if I go back to here, I'm going to, when the power is on, I'm going to invoke an actor. I'm going to zoom out so I can see where that button is. There we go. And I'm going to invoke an actor called audio player. Zoom into that. And very importantly, I'm going to give it an ID. Because I'm creative, it is also going to be called audio player. And then what I'm going to do is I'm going to add an entry action to power on. Now, this is a very special kind of action, and it is a send to action. This is built into XState, which I will mention a little later. But this is saying I want to send an event to the audio player, and that event type is going to be play. And on exit, I'm going to, again, use a send to action to audio player. And I'm going to send pause. Can't type, pause. There we go. So when we enter power on, we're going to send that play message over to the audio player. And when we exit power on, we're going to send pause. It's not stop because the web audio API doesn't pay attention to stop. It likes pause. So that's fair enough. So having a state chart like this is really great because it is actually executable code. And one of the things that we can do in this situation, let's hide you. You're going to be able to see this well enough. You'll get the idea, it'll be shapes. Is you can, oh, that's that space. Power off, why are you hiding in there? There we go, that's better. So now I can simulate my machine. So all of these red buttons, in fact, I'm going to open this so you can see a bit better, these are red buttons, blue buttons, are different events that we can hit and to move to an available state. So right now, I am in the power off state, and so I can hit toggle power. And then all of these other events become available to me. I'm in the sound state and the light state, and I can toggle in my sound state. I can toggle, and now I'm in the fan state. And I can toggle, and now I'm in my wave state. And now I can toggle, and I'm back in my white noise state. So I'm simulating exactly how my application logic is going to work. And I can do the same thing simultaneously with my light state. So I can toggle my light to yellow. I can toggle my light to blue. I can toggle my light to green. And I can do the same with hitting volume up and volume down as well. Now, I don't know if you've noticed here, I actually have a mistake in my machine. Has anyone noticed what the mistake is? There's a fundamental flaw in my logic. And that is that I have no way to get back to power off. So that's one of the great things about simulating your machines, is that you can very quickly find these things. So if I zoom in here, and I'm going to create a transition back, not a state done event, which is a bog standard event to go back to toggle power, back to power off. And now if I go back to simulate, I can toggle my power on, I can toggle my power off, I can toggle my power on, and continue going just like that. So through this demo, you might start thinking, wow, this is so easy to understand, and even that really not very clever person in the office might even grasp the concept of this, and Laura doesn't even have to explain that much. This is because diagrams are great. So diagrams are great because there's a visual representation of your code, very clear communication when it's visual like that. So it's also really easy to collaborate. And that makes it easy to spot errors, which is great for documentation. And all of this helps with much better planning and organization, if everyone on your team can understand what's going on with your diagrams. And state charts provide all of the wonderful benefits of diagrams, but also being executable code. So having your application logic be both visual and executable, it makes for much better living documentation, and it actually makes for a really valuable source of truth. You don't need to have a file, a JavaScript file somewhere, or even a whiteboard somewhere, or something that says final, final, final. Yes, this is the current version of our logic. Use this one. It's not in someone's head. It's in a diagram that everyone can understand. So going back to the problems that we have in software development, the modular and hierarchical structures in state charts, that helps you handle complexity better. The explicitness and the clarity makes that complexity much easier to understand. The visual representation is really good for internal documentation. Imagine making an update to your app logic, and in your PR, it has a diagram that shows exactly what's changed. Everyone understands it. And we have a much clearer structure for testing and debugging as well. So now I'm going to go into the novelty section and start adding some colors, because that is just fun. Because another thing that makes things easy to share is just when they're a bit visually appealing. So I'm just going to pink for white noise, yellow for my fan, blue for waves. Well, the colors speak for themselves here. I've got to do yellow for the yellow state, and blue for the blue state, and green for the green state. And even just little things like this, helps you draw attention to the particular parts of your diagram that you want to share with people. You could do things like have red for all of your errors. You could have green for your happy paths through your logic. It makes it much easier to share it all with your team. So what you say is, Laura, show me the code. I want to see the code. So if I go to export this, Now here I do have the option to go to TypeScript. I'm a little bit scared of TypeScript. I'm going to need to watch Josh's talk tomorrow to help give me a bit more confidence again. So I'm just sticking with JavaScript for now. We also have JSON and some few other exciting formats. But here is our little state machine in JavaScript form. This is using XState, which is a library for state machines that runs anywhere that JavaScript runs. And if you've used state machines on the web, you've probably heard of it. If you haven't heard of it, well, something you use probably uses it. Like XState is in cars, it's in smart TVs, it's behind a lot of e-commerce functionality. Even games are using XState as well. So you may not have heard of it yet. When you know to look out for it, you'll notice it everywhere. And so so this is the object that we have. I'm going to make this a little bit wider, a little bit zoomier. Ah, wonderful. So here we can see that this is essentially the machine itself. Just zoom it. Don't want that in the way. The machine itself is just a JavaScript object. So it's very readable, actually, in itself. If you prefer to write state machines in code, you can do that and have fun. You can still interpret them as visuals as well. So you can see things like this. We have a power on state. Here are entry actions. It's a show buttons action. It's very easy to read. And if I scroll all the way down to the bottom, here you can see we've got space to add the implementations for all of the actions that we've got in there. We've also got for the actors that we've got in there, and for our guards as well. So the great thing about XState is it doesn't just contain your state, it actually enables you to orchestrate your state. So now I'm going to open this. Now, wish me luck with the demo gods that this is going to open in StackBlitz. Come on, internet. Yes, right. It's called the machine unknown. So exporting this to StackBlitz has just generated a really basic little template that is pretty similar to the simulate mode that I showed you before. It tells me what my current state is. I can toggle it, and now you can see all of these other events that are available to me. I can toggle the sound. These are all my current states that are currently active. I can toggle my light. You can see that it's in the on state, it's light, it's yellow. So you can toggle and go through that quite easily. But if I jump to a version I made earlier, now here you can see a wonderful error that I've got going on. Now what I'm going to do is I'm going to export this machine that I have just created in front of you, so we all hope that it works. I'm just going to copy the code for now, and I'm going to paste it into this machine.js file. Oh, things are happening. Very exciting. Now, this is exactly the state machine that I showed you a minute ago. Zoom a little tighter into that. And if I just quickly show you here, this is a little bit of HTML, a little bit of JavaScript, that kind of good stuff. It's not very much code. This is just the implementations. If I go, in this one, I'm actually going to show you for sure. Oh, Laura writes bad JavaScript. OK. So here, if I zoom in nicely, you can go away. This is the machine provide method. And what this is doing is it's giving me a location to basically provide all of those implementation details for what I had before. So here I have my set volume. That's adjusting the context there. Here's the showing buttons, hiding buttons, removing the color, and all of these going on. And my volume up, my volume down. My actor is a callback actor, which is a very cool logic that you can get out of XState as well. See, it's very readable. You can work out what it is. And that is my guards as well. So now, I'm going to play my machine. The moment of truth here, hoping it works. I'll zoom out a little bit, so otherwise my CSS looks bad. Right. Power on. A little bit better CSS. I have a white noise machine. It's working. OK, see if the internet wishes me well, I'm going to be able to change the sound. to a fan. Yes. They're not the best looping clips. This is doesn't measure up to Rowdy's talk at all in terms of audio specialness, but it's kind of soothing. Okay, waves. Ah, that's relaxing. You know what would be really relaxing with waves is if I switch a light on. Ah, yellow. Oh, blue, that works too. And green. And my volume up, does that work? No. Volume down? Oh, yes, that works. OK, there's something wrong with my volume up code then, but my volume down is working, so that's useful. And if I power off, so I have an issue. I've powered off, but my light is still somehow on. So this is one of the good things about state machines and having my logic completely separate from my code. So I can go here, and I can see where is the problem. So the problem is that I've got light, I've got the remove color action there, and I actually think I'm going to add the remove color as an exit action when I exit. Yes, when I exit the light state. So I'm going to add remove color there. Right, let's get that code again and return back to, that's the right one. There's my code. There we go, you can go away. Get my machine, replace the code in my machine. Now hopefully, it's time new tab. Oh, that's very white, I do apologize. Too bright. And, okay, sound is working. Fan is working. Light. Turn the power off. Yes! So it makes it really easy to be able to detect those things and get them fixed, make it easier to maintain as well. It's because I've got all of that logic separate. So, do you always need a state machine? Well, no. Especially if you have very simple or linear logic, it would be too much. It would be overkill. If you have small and isolated components already, you may not need a state machine for that. When do you need a state machine or a state chart? Well, the rest of the time. If you have complex systems, when you want to make it easier to document and debug and to test, when you need to be able to communicate your application to logic to someone who is not an engineer, or really even any other engineer, to have that single source of truth that you can share with your team. And of course, when you want to create state charts, I would recommend XState, and also Stately. So Stately is what I use to create that state machine that you saw there visually with the drag and the drop. And also all of the graphics in this keynote was also created using Stately. That's not what it's designed for. It's just, I love it so much, I want to use it for everything. If you use the code DevReach, I got you a special promo code. You can try out all of the pro features, like the cool colors and stuff like that, for free for 60 days. That is double the usual time. And that will be good through to the rest of 2020. Yeah, we're in 2023. Yeah. So returning to my white noise machine, arranged a little nicer. Imagine all that code and complexity distilled into a visual form. Of course, as I said earlier, you can still write it as code if you like. If you are someone who uses XState already, the very few of you, you'll know that you interact with XState using code already, and making it visual is just another layer on top. And it's shareable with the entirety of your whole team. The whole of your team can collaborate together on the logic of your application. You can get your requirements and easily and quickly translate it all into code. It's quite fun doing like a brainstorming session, just all sitting together, like, oh, what events do we need? What states do we need? Maybe that's just the kind of fun that I have. And obviously, I don't mind if you don't use XState or if you don't use Stately. I'm not here as a salesperson. But I do very much recommend that you give state machines and state charts a go. Thank you very much for having me.